So today we are going to go back to Cougarville. So in Cougarville, there is Miss Little. So Miss Little is a person who runs a daycare center. And her daycare center is known as Small Cubs. And it is possible some of you may have gone to her daycare when you were little.
Oh, yeah.
And Miss Little has been planning to expand her daycare activity. I mean, she's a businesswoman and she wants to make more money. So she's interested in expanding the daycare center. And she's been planning for that for the last 6 months. But yesterday, she happened to read the newspaper where it said that in the country, the birth rate is dropping. So this seems to worry Miss Little. If she's going to expand the daycare, and if the birth rate is dropping in the country, and if it affects Cougarville, then she may not have a lot of customers. So she is in a panic. At the same time, there is Mr. Goodfellow, who is a healthcare professional. And he's the person who takes care of any kind of medical emergencies and facilities in Cougarville. And he is also in a panic a little bit because the same news story which talked about the drop in birth rate in the nation also talked about an increase in the aging population. So Mr. Goodfellow is a little bit worried because he is not sure whether Cougarville has the facilities to take care of the short term, the medium term, and the long term healthcare needs of an aging population. So both Miss Little and Mr. Goodfellow don't know what to do, how to plan for these situations where the birth rate is dropping and the aging population is increasing. So they decide to get some help. So what do? They go to our friend, Mr. Smartalek. So they go to Mr. Smartalek and tell him that they have this problem. The birth rate is dropping, so can Miss Little plan on expanding her childcare facility? And then Mr. Goodfellow, how can he plan for the aging population? So Mr. Smartalek talks to them, and he gives them an idea. He tells them how to determine what the population in different categories of ages will be in the next 10 years or in the next 20 years, based on what the population is now. So Mr. Smartalek is trying to tell them how to determine or how to estimate the population in the next 5 years, 10 years, or 20 years based on what you have now. So he talked about a couple of different things. One is called the population pyramid, and the other one is the Leslie matrix. So what we are going to do today in this class is to look at the population pyramid and the Leslie matrix and see how we can use these ideas to estimate what the population will be in 10 years' time, for example, if we know what the population is today. So let's look at the population pyramid. So what is a population pyramid? A population pyramid is a figure which looks like a pyramid like this. But then here the population is divided into two groups, males on one side and the females on the other. Then what we are doing is we are looking at the population in different age bands. And typically, an age band will be like 5 years. So you are looking at the population of Cougarville between ages 0 to 4, then from 5 to 9, and so on up to 75 to 79. Then beyond that, it's like ages 80 and above. So if you look at the census for Cougarville today, and based on that, you can determine how many people are going to be in the age band from 0 to 4, 5 to 9, and so on in terms of males and females. And typically, the figure will look like a pyramid, like you see in this picture. So that's why it's known as a population pyramid. But in real life, if you look at different countries, you may have population pyramids which look like a pyramid, or there could be a population pyramid which look more like a box, or there could be a population pyramid that looks like a inverted pyramid. So this is like the typical pyramid, and this is a box, and this is the inverted pyramid. So where will you get a figure which looks more like a pyramid? For which country? If you look at this figure, it's pyramid. So if you look at the base, it is broad, and when you go up, it is narrowing down. So what that means is the population at the base, that's when you are looking at ages from 0 to 4 or 5 to 9 and so on. So they have a lot of young people there. And when you go up, you're getting narrower. What that means is the number of older people is getting smaller and smaller. So what that means is this kind of pyramid is true for a country where you have a high birth rate, but then the life expectancy is short. So short life expectancy. So this is true for a country which may be a developing country. Now let's look at the box pyramid. So when you look at the box pyramid, there the base, that is where the young people are, and the top, that's where you have the population of the older people, are almost the same. So what that means is there you have a birth rate which you can call kind of moderate, and then the life expectancy is high. So there are more older people still living. So this will be true for a country which is a developed country. Now what about the third kind of pyramid, the inverted pyramid? So it is inverted, so at the bottom you have a small number of younger people, 4 or 5 to 9. And when you go up, you have a large number of older people. So what that means is here the birth rate is rather low, but the life expectancy is still high. So this is also true to some developed countries where the birth rate is low compared to this country with the box where you have a moderate birth rate. So you can get these 3 different types of pyramids if you look at the population of different types of countries. So now what we are going to do, we are going to see how we can estimate the population at a later time. So what that means is we are going to assume we know the population in this band from 0 to 4. Then we know the population in the next band from 5 to 9 and so on. So what we want to do is what happens if we fast forward 10 years, then what kind of pyramid are we going to look at? So then you're going to have a different kind of pyramid, and then how the population from 0 to 4 changed into whatever population we are going to estimate, and the population from 5 to 9, how it changed into a different population we are going to estimate. So this is the pyramid we are going to estimate. So this is where the concept of Leslie matrix comes along. So in order to describe the Leslie matrix and how we can use the Leslie matrix to estimate the population at different age groups, we are going to look at a simple example. So the simple example we are going to look at is this. So let us say you have a species, and we are going to look at the 3 different stages of the species. The first stage being egg, the second stage being larva, and the third stage being adult. So these are 3 different stages we are looking at. So the egg will turn into larva, and then it will turn into adult. So in this particular example, we are going to say when you go from one time period to the next time period, 5% of the eggs will turn into larva. What that means is 95% of the eggs die. So the survival rate of the egg to larva is 0.05. In a similar fashion, from the stage larva to adult, only 40% will turn from larva to adult. So again, what that means is 60% of the larva will die. So the survival rate of larva to adult is 0.4. Also, we have this number 75 going from adult to egg. What does that mean? That means in one time period, on average, one adult will lay 75 eggs. Okay? So this is a simple example we are looking at. So we have 3 stages, and in one time period, we know how these different stages interact in the way eggs become larva, and the larva becomes adult, and the adult laying eggs. So what I'm going to do, I'm going to write down a matrix, and the matrix will look like this. That's the Leslie matrix. So if you look at the first row of this matrix, that will describe the fertility rate. Okay? So the elements in the first row are supposed to describe the fertility rates. So in this particular case, we have only one, the adult laying eggs. So it's 75. So that's why you got the number 75 there. Then the elements in the rest of the matrix, they describe the survival rates. So we said the survival rate when you go from egg to larva is 0.05. So you got a 0.05 as an entry in this matrix. Then we said from larva to adult is 0.4. So you got a 0.4 as an entry in this matrix. Then we have a vector, and that's known as the population vector. So in the population vector, in this particular example, the first component, that corresponds to the first stage, that is the egg. And the second component corresponds to the second stage, that is larva. And the third component corresponds to the third stage, that is the adult. So what we have here is a vector that tells you at the beginning how many eggs were there. So in this case, 1,000 eggs. The number of larvae, 100. And the number of adults, 10. So that's the number of eggs, larvae, and adults at the beginning of the process. Then on the left-hand side to that, we have the Leslie matrix that tells you the fertility rates and the survival rates when you go from one stage to the other. So now what you do is you multiply that population vector by this Leslie matrix. So when you multiply these matrix and the vector, what you're going to get? Okay, the first one is going to be you're going to take the first row, that is 0, 0, 75, and you're going to multiply that with this population vector, the column vector, that is 1,000, 10, 100, and 10. So when you multiply, it's going to be 0 times 1,000, which is 0. Then 0 times 100, which is 0. Then 75 times 10. Remember, there are 10 adults, and on average, one adult can lay 75 eggs. So 75 times 10, that's going to be 750 eggs. So in the new vector, you will have 750. That's the number of eggs you are going to have in the next time period. Now let's come to the second row. Now the row is going to be 0.05, 0, 0, and then you're going to multiply that with the population vector 1,000, 100, and 10. So now remember, the survival rate from egg to larva is 0.05. So you have 0.05 here. So when you multiply, it's going to be 0.05 times 1,000. That's going to be 50. Then you have 0 times 100, which is 0. Then 0 times 10, which is 0. So all you're left with is 50. So what that means is, at the next time period, the number of larvae is going to be 50. Now we come to the last row. So the last row is 0, 0.4, and 0. Then again you multiply that with your population vector, 1,000, 100, and 10. Then what's going to happen? It's going to be 0 times 1,000, which will be 0. Then 0.4 times 100, that is 0.4 of the larva, that's a survival rate, is going to become adult. So 0.4 times 100, that's going to be 40. Then 0 times 10, that's going to be 0. So we'll have 40 new adults in the next time period. So you get 40 there. So what we have shown is this, that is, if you are given the population at a time, and if you know the population and how they are divided into different stages, in this case the stage of egg, larva, and adult, and we had 1,000 eggs, 10 larvae, and 10 adults. Then if we know the fertility rates, and if you know the survival rates between the different stages, then we can find, or we can estimate, what the population is going to be in those different stages at the next time period. In this case, it was 750, 50, and 40. Now let us say we want to do that for a second time period. If you want to do that, how will you do it? All you have to do is to just take the same Leslie matrix, which is 0, 0, 75, then 0.05, 0, 0, 0, 0.4, 0, and then you need to multiply that with the population vector that we just obtained. The new population vector, which is going to be 750, 50, 40. So when you do the multiplication now, you're going to get some answer, and that is going to give you the numbers for the different stages of egg, larva, and adult in the second time period. And you can continue in this fashion for, let us say, 10 time periods. Then you will have the estimate at the 10th time period. So this is the idea Mr. Smart Aleck gave Miss Little and Mr. Goodfellow. So you can apply the same idea to the population of a city or a population of a country. But now in the case of a city or a country, again remember, we were looking at a population pyramid, and there we had the different stages in terms of ages. We have age band, and every age band is 5 years, 0 to 4, 5 to 9, and so on. So when you want to do the same idea for a population of a city, now your matrix is not going to be a small matrix like this. It's going to be a larger matrix, depending on how many age bands you are going to have in your population pyramid. And your population vector is going to be similarly large, depending on the number of age bands you are going to have. But the concept is going to be the same. So after talking to the Smart Aleck, Miss Little and Mr. Goodfellow felt a little bit relieved, because they can go back and do the calculation based on what the population was in Cougarville at the time and estimate what is going to be the population in 10 years' time at different age groups. And that can give them some kind of estimate to plan for the future.